Hello, welcome to Python video lecture series. Today we will discuss about MicroPython. Request to like, share, comment, subscribe and do not forget to press bell icon to receive latest video information from this channel. Here outline of the presentation is there. In today's lecture we will discuss why we need to learn MicroPython, then history, then difference between Python and MicroPython. Then supported board for the MicroPython, especially PyBoard and ESP32. And lastly, references there. Why MicroPython is needed? Python is one of the most widely used, simple and easy to learn programming language around. So the emergence of MicroPython make it extremely easy and simple to program digital electronics. If you have never programmed digital electronics before, MicroPython is good starting point. MicroPython is goal to make programming digital electronics simple as possible. So can be used by anyone. Currently, MicroPython is used by researcher, teacher, educator, even in commercial product. MicroPython is a re-implementation of Python 3 targeted for microcontroller and embedded system. MicroPython is very similar with regular Python. MicroPython runs bare metal directly on the hardware. There is no underlying operating system like Windows, Mac OS or Linux. All the operation and service usually provided by an operating system are handled directly by MicroPython. MicroPython has complete and direct control of the hardware. So in fact, MicroPython is the operating system. History. MicroPython was originally created by Australian programmer and physicist Damien George after a successful Kickstarter-backed campaign in 2013. While the original Kickstarter campaign released MicroPython with a PyBoard microcontroller, MicroPython supports a number of ARM-based architecture. MicroPython has since been run on Arduino platform-based product ESP8266, ESP32, and Internet of Things hardware. Now discuss difference between Python and MicroPython. MicroPython does not support the entire Python standard library. If a module is missing, it will be due to the inapplicability of the module for use in embedded controller. High memory consumption or lack of certain required hardware feature multiprocessing are reasons that some modules cannot be implemented for the microcontroller. Difference by design. MicroPython is intended for constrained environment. In particular, microcontroller which order of magnitude less performance and micro memory than desktop system on which C Python 3 runs. This means that MicroPython must be designed with this constrained environment in mind, leaving out features which simply will not fit or will not scale with targeted system. MicroPython does not ship with extensive standard library of module. It is not possible and does not make sense to provide the complete C Python 3 library. Many modules are not usable or useful in the context of embedded system and there is not enough memory to deploy the entire library on small device. So MicroPython takes the minimalist approach. Only core data types are included with the interpreter and all the rest is left as a third-party dependency for the particular user application. The MicroPython lab project provides a non-monolithic standard library for MicroPython. Unlike CPython 3, which uses reference counting, MicroPython uses garbage collection as the primary means of a memory management. MicroPython does not implement complete CPython object data model, but only a subset of it. Advanced usage of multiple inheritance -new method may not work. Method resolution order is different. Metaclass are not supported. MicroPython design is not based around descriptive object. So far, we were able to implement all native Python features like property without explicit descriptors. Descriptors are considered over-dynamic feature and conflict with the aim of being fast and efficient. However, simplified support for descriptor is now implemented as an opt-in feature. By virtue of being MicroPython implement only subset of functionality and parameter of particular function and classes. Each specific issue may be treated as implementation difference and resolved, but there unlikely will be cover 100% coverage of CPython feature. So by virtue of MicroPython support only minimal subset of introspection and reflection feature, such as object name, docstring, etc. Each specific feature may be treated as implementation difference and resolved, but that unlikely will ever be 100% coverage of CPython features. Print function does not check for recursive data structure in the same way CPython does. So there is, however, check for stack uses. So printing a recursive data structure will not lead to crash due to stack overflow. And note that it is not possible to implement more CPython like handling of recursive data structure on the Python application level. Do this by writing a function which keeps the history of each object visited and override the built-in print with your custom function. Such an implementation may of course use of lot of memory, which is why it is not implemented at the MicroPython level. MicroPython optimizes local variable handling and does not record or provide any introspection info for them. Like locals does not have entries for locals. Implementation difference. Some features don't cater for constraint system and at the same time are not easy to implement efficiently or at all. Such features are known as implementation difference, and some of them are potentially the subject for future development after corresponding discussion and consideration. Note that many of them would affect the size and performance of any given MicroPython implementation. So sometimes not implementing a specific feature is identified by MicroPython target users. Non-issue. Non-issue are essentially bugs, missed features, and omission considered such and scheduled to be fixed. So ideally, any entry should be accompanied by a bug ticket reference. But not that this non-issue will be have different priority, especially within wider development process. So if you are actually affected by some issue, please add detail of your case to the ticket or open it if it does not yet exist to help planning. Submitting patches is even more productive. Please note that the list of not implemented modules or classes include only those which are considered very important to implement. Furthermore, MicroPython does not provide full standard library in general. Board support. MicroPython runs on many different devices and boards such as ESP32, ESP8266, PyBoard, Teensy 3.x, Wi-Fi, PyCom, Adafruit Circuit Playground, XPace. PyBoard. The image represents MicroPython PyBoard version 1.1. The PyBoard is the official MicroPython microcontroller board with the full support for software features. The hardware has STM32F405 RG microcontroller, 168 MHz Cortex M4 CPU with the hardware floating point, 1024 KB flash ROM and 192 KB RAM, micro USB connector for power and serial communication, micro SD card slot supporting standard and high capacity SD card, then 3-axis accelerometer MMA 7660, then real-time clock with optional battery backup, 24 GPIO on left and right edge and 5 GPIO on bottom row, plus LED and switch GPIO available on bottom row. 3x22-bit analog to digital converter available on 60 pins, 4 with analog ground shielding, 2x12-bit digital to analog converter available on pin X5 and X6, 4 LED red, green, yellow, and blue available. One represent, one reset, and one user switch as there. Onboard 3.3 volt LDO voltage regulator capable of supplying up to 250 milliampere input voltage range, 3.6 volt to 60 watt. And DFU bootloader in ROM for easy upgrading the firmware. Then ESP32. This image represents ESP32 development board. Why the ESP32 things? MicroPython is supported on many different microcontroller platforms and more are being added all the time. The ESP32 is a great tool for learning MicroPython, as it has powerful controller 240 MHz with lots of RAM 520 KB. Additionally, the ESP32 has a built-in Wi-Fi module which make networking and connecting to the internet quite easy. These are the list of the reference. Thank you. Request to like, share, comment, subscribe and press bell icon to receive latest video information from this channel. Thank you.